Okay, so probably going to get interrupted by announcements, but I just want to quick get this video to you. When a skydiver jumps out of a plane, her initial acceleration is negative 9.8. As the diver falls, the acceleration goes down at a rate of 0.68 meters per second squared per second until it reaches zero acceleration. What does terminal velocity mean in terms of the diver's velocity and acceleration? All right, so terminal velocity. I hope you all know what that is. You can look it up if you don't. Well, basically, the acceleration equals zero at what we call VT for terminal velocity. All right. Graphs, do your best. This one I want to help you with. Based on the given information, derive the acceleration function. All right, so it starts off with an initial acceleration of this. It changes, goes down at a rate till it reaches zero. Okay, so this is an object accelerating down, right? It's in free fall. It's accelerating down initially at negative 9.8 meters per second squared. But because of air drag, as it falls, that acceleration decreases until it gets to zero. And it says you can assume it's a constant rate of change. So this follows, you know, just like the old velocity equation follows the form v equals at plus v naught. Well, we just take this up a level like we did with the other equations on the last problem there, problem 6. Basically, this follows the form of a equals, well, it's rate of change of acceleration, which is a jt plus a naught. But we really don't like to use that symbol j very often, the jerk. So that's the rate of change of acceleration. And note, it goes down. We're not going to make this negative. We're not going to make this negative because we have a negative acceleration. So that's a is down. The rate of change is up. It's in the positive direction. Remember, signs represent the direction. So what we have is positive 0.68 meters per second squared per second times t minus 9.8 meters per second squared. All right, so determine the time to reach terminal velocity. All right, well, remember, at terminal velocity, the acceleration is zero. So basically, you're determining t when a equals 0. So you got to use the function up there to do that. Determine the terminal velocity. Well, once you get the time here, you know, change in velocity equals the integral of acceleration with respect to time, right? So the time you're going to use from 0 to t, well, it's going to be the time you calculate here. Like, it's going to take this long to get to acceleration equals 0. So therefore, put that in an upper bound of our integral. We solve for the change of velocity, starts from rest, find the final velocity, and then whatever antiderivative, the antiderivative of acceleration gives us velocity, the antiderivative of velocity gives us position. So delta x is then going to be the integral from 0, that same time, 0 to t of v dt. And you're going to use the antiderivative you find when you do part E. Going to put that in for v, take that integral, and then solve it. All right, that's number 7. Number 8, you really do need to graph this to get the function. It's going to be like a side opening parabola. You're going to put a fit line on it, quadratic fit line on it, tri-fit. It'll only take you, you'll be able to plot it pretty quick. You're going to write the equation. How much time after how much time does the acceleration reach 0? So you're going to take the derivative of the velocity function, a equals dv dt. V is going to be, you're going to determine that from the graph. And then you're going to say, okay, put in 0 equals the derivative. What's the top speed? Well, again, that's the v when a equals 0. It's the terminal velocity again. So when it gets to that time, so you're going to have to say, okay, again, delta v equals the integral of a dt from 0 to t where, again, you're using the time from part B to figure this out. Does this function make sense at time equals 20 seconds? Why or why not? What does this mean about your function you produce? Use log or pro if necessary. So put in 20 for the velocity and see what happens. All right? Or 20 for the time into the velocity function and see what that looks like. See if it makes sense or not. Wrap these up for homework. Have the solutions posted. Take questions on them. Good luck to you. Talk to you later.